that's fine. That's a video. I can picture what you're doing.
Yeah, that's the complete code, and then that's what it's returning. Previously for the microcontroller and the I2C bus. Now I have added the power supply unit with the battery and the voltage regulator, which is all over here. So we've got the battery terminal, the lithium-ion charger. These here are now useless, but they can be used for anything that requires power if needed, straight from the battery. And we've got a smoothing capacitor that goes between the voltage input from this one, from the regulator, and the voltage output is filtered by the little ceramic capacitor. All the power goes through the voltage regulator, and then the power supply goes then to the microcontroller. So we have a little LiPo battery that I can plug into here. So that one goes in there, clips in that little JST plug, and then I can test all the voltages. It's working plugged into USB, but it wasn't working a second ago plugged into this, so we'll try and troubleshoot this. I'm with a friend and helping out. We've figured out what the issue is. This solder here, which is very messy, is not contacting between the ground intake and the ground where it contacts onto the microcontroller. So we're going to have to fix that one, and then we should be on our way. Truth, let's plug the controller in. That's him. Now let's plug the battery in. See if this is going to work. Ooh, look at that. Beautiful. Successfully got it running on my LiPo battery. The ME280 sensor for the temperature, pressure and humidity of the battery into here, and charging the battery just at the moment with a USB. Later on, obviously, that will be with a solar panel. So this little sucker arrived in the mail, and tested out the spacing, and all seems to. This board has been a little bit rocky, but there's been a few things go wrong. However, I've got 2 Hall sensors in there at the moment, and they are working wonderfully. So we'll just bring the magnet over one of them. Should print east, and then the next one northeast, and over them both northeast. So it's working correctly. I did, however, run into an issue where these pins down here that say VDD, which is voltage drain, I didn't realise, and I thought they were VCC, which is the supply. So I've had to do a little bit of extra jumper wiring back here and take out those pins to actually supply all of the sensors with voltage. southwest one being a little bit shorter to ground, causing problems. I finally got it to work exactly how I want. Oh yeah. And go out in the wind. Heck yeah. Alright, it's been a while since I've done anything, but just hooked up the one Hall effect sensor to just a simple LED circuit to make sure it's gonna work. So chuck that on there. Give that a bit of a spin. That's working, that's good. Just to make sure it's going to work out higher speeds. A bit questionable there. Check all the connections. Yep, it works. Okay, good. Calibration, it is fully functioning. The battery and it's working. All the bugs I've ironed out of it, and yeah, it's measuring the wind direction very nicely. It's measuring the other environmental data very nicely, and the only thing is this one now just needs calibrating to wind speed rather than revolutions per minute, and it is done. It's finally in all the glory, all operational. That's now calibrated to be actually kilometers per hour instead of just revolutions per minute. That's all working nicely. The temperature, humidity and pressure is working lovely. So glued together in this case, and the only thing I need to do now is put on a little solar panel, which is on its way. Connected, the three sensors here connected, the battery, and now I just got to put the lid on the solar panel, and that'll be everything fully together. So now I got the, oh, it's hard to do with one hand, the lid, plug that in. Now that's plugged in and charging. Just lower everything down in here. Really, really gently. Put that on. We'll screw that in, and then that, my friends, is complete. Look at that beautiful structure.